Hey there, kiddos. Welcome to Dalton's Law of Partial Pressures today. So, partial pressures, can you tell me a little bit about that?
So if I have this cup and I catch a bunch of air in it,
Okay.
So now I have all kinds of gases in here, right? So
All the stuff in the atmospheric gases, right?
So what kind of gases do I have in
Okay.
there?
Nitrogen, oxygen, carbon dioxide, argon, and a bunch of other stuff too.
Water vapor maybe.
Water vapor as well.
So now all of these gases are colliding with the sides, and that's where our pressure comes from. How many times or how frequently they're hitting the sides of the container. So if I add up all of the partial pressures, I get the total pressure of the container.
Each gas that's inside there has a certain pressure it exerts, and you add them all together to get the total pressure inside.
That's all you're doing.
Okay, I think we can actually do a couple of examples just to how to calculate this. So let's look real quick at the equation for Dalton's Law of Partial Pressure. So the total is equal to the pressure of one gas plus the pressure of another gas, partial pressure anyway, plus the partial pressure of the third gas, blah, 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 all the way to the nth gas, which is like however many gas there are. N means the last gas.
Okay.
So do you have a problem for me? Do you want me to solve here?
So if we have hydrogen gas and oxygen gas, and the hydrogen gas has a pressure of 0.72 atmospheres.
Okay.
And our oxygen gas has a pressure of 0.53 atmospheres. We want to know what the total pressure is. We can just plug that into our equation.
Okay, so we've got a container that has just those two. So this is pretty easy. We just say the total pressure is the sum of these partial pressures. So the first one is 0.72 atmospheres. The other one is 0.53 atmospheres. Add those together.
And we had the same units, so you didn't have to do any conversions. Make sure you keep track of that.
Yeah, if we had one was in atmospheres and one was in millimeters of mercury, we'd have to convert one of them in order to make that work. So this is the same units. This is equal to let's get that decimal, 1.25 atmospheres. This is simple addition, folks. That's all it is. So that's just if we were given the partial pressures. What about if we're given the total?
To solve for another gas? Okay, so let's say we have a total of 10.5 atmospheres.
Okay, let me get this all erased here.
And we have 3 gases.
Oh, we have 3 gases this time. Okay, so our total is
10.25. 10.5, I'm sorry.
10.5 atmospheres, right? And we have 3 gases, P1, P2, and P3. Okay.
Okay, so P1 is 2.56 atmospheres. And P2 is 5.21 atmospheres. So again, we have all the same units.
Okay.
And we are trying to solve for the third one.
Okay, so this is pretty easy. We just set up our equation with our numbers. The total, which is 10.5, is equal to the first one, which is 2.56, plus the second one, which is 5.21, plus x. Okay, so what we're going to do, all we got to do here is combine like terms, right? And then subtract it from
both sides.
Subtract it from both sides. So basically 10.5 minus the sum of that gives me the third one, which is equal to what?
2.73.
2.73 atmospheres. Again, pretty easy. This is just pretty simple addition and subtraction. Not a whole lot to it here, except now, what if we had water vapor as one of our gases?
So for water vapor, there's this really nice chart of the pressure at given temperatures.
Okay.
Because the pressure is known.
So I'm just going to write this out.
So you'll have to look at the chart to find the pressure of the water at that temperature. Same thing, you just have to use a chart also.
So let's pretend we've got 3 gases in a container, one of which is water vapor.
Okay.
And what temperature are we at here?
Let's say 25 degrees Celsius, which is about room temperature.
Okay, let's say the temp is 25 degrees Celsius, and the pressure of the water vapor is what we're trying to find, right?
Yeah.
Okay. Actually, we're trying to find the total.
Right, we're trying to find the total. We need to use the chart to find the water vapor.
Okay.
So pressure of the first gas is 63.5 kilopascals.
Kilopascals.
So again, different units than we used previously. And the second gas is 35.0 kilopascals.
Okay, hopefully this works here. So we're going to try to find the total, but we got to look at our chart to figure out what's going on here. So let's switch to our chart real quick, and we look at 25 degrees Celsius. It is on the right-hand side, and 25 degrees Celsius, water vapor pressure is 3.2 kilopascals.
Okay.
So let's write that in.
So 3.2.
And we would give you the chart every single time. So basically all we got to do is add up those three numbers, right?
Yep.
So our total with all those added together would be 101.7, I believe.
Yeah.
Kilopascals.
Yeah, you got it.
Hopefully my math is correct. So that's basically it. You just have to use a chart for the water vapor. Everything else is just adding up the pressures. Make sure they're in the same units though.
That's the only trick.
All right.